Hello everybody, this is Khashayar and welcome to another tutorial in Pygame. In this tutorial I'm trying to create a basic physics, not something like rigid body physics, something that covers the gravity and player movement, which is not part of the physics, and the collisions. So we start with a simple class that represent a player, and after we fix the player movements and we continue with the gravity. So everything here is the same as two other tutorials videos. We have three files. One is main, not this one in fact. One is, I rename it to platformer physics, which is just simple game loop, and another one is the assets, same as what we used last time with the sample image that we use it for, I think, for rotating, and the monster animation for the animation part, and the settings file is the same. Everything it's just screen width and height, and initialize the Pygame and this kind of stuff. So we go back to our platformer physics file, and when we run it, it should have just empty screen, blank. Okay, we create a class here. We can name it, let's call it entity. Again, everything is same as 2-3 other classes which we created. So I'm going a little bit faster without too much of speaking. Pygame.sprite. Here we can also pass image parameter, but for now we are not going to use any external image. Set that x equal x. And set that height equal height. And now set that image equal Pygame dot surface, and pass the self dot width, set that width, and self dot height. And we use, actually this should have, we should use them in another tuple. Okay. I guess we can also use a list for that. And self.image.fill pygame.color, let's use green, maybe it's good. And now we get the rect, self.rect equal pygame dot self.rect equal self.image dot get rect, and self.rect dot top left equal the position of self.x and self.y. Let's for now create an object or instance from this class. We call it player equal entity, and it will be, let's put it on 100 and 100 and 32 pixel. Now, like before, we use the container classes here, like all the sprites, all Pygame dot sprite dot group, and we add the player something like this, all the sprites dot add player, and here again we create three sections: updates and logic, and here a render, and in render we can use all the sprites that draw on the screen. And we can also use all the sprite.update, but so it can have access to entity class update, but because I'm going to implement in a different way for now, and something like manually updating the player object for gravity and collisions, so we don't even need to use all the sprites.update. So I guess we should have our player object on the screen now somewhere. Nope. Entity object has no attributes as image. Line 19. That's very strange. So set that width, set that image, Pygame.surface field. Okay. Yeah, because it's typo. Here is typo. Set that image. Yup. Now we have it. Okay. What next? Next, we need to have a couple of different attributes. And we need to have gravity, the movement, and the speed. So we can have also something like constant, even in our settings, like we make the gravity here equal something, some number or something, but we put it in the entity class. So self dot gravity or g equal 0.99. 99 here self dot move. We can use something like this way, something like this. It's like a vector, but also you can, this depends on your preferences. You can also use something like self dot variable like exchange equals 0 self dot y underscore change and equals 0 and deal with them separately, or you can use a list of two numbers like a vector 2D and deal with them in this way. And also here self dot, so we just use self dot move with something like the vector 2D. Self dot speed equal 4 for now. And let's create this define update just in case, self and pass. Okay. Okay. So everything, all these player moves we can also implement in update or create something like define, I don't know, movements, self, and separate it. And here we can also define something like get gravity or apply gravity and separate all of them. But I'm not going to do it that way. I want to implement everything in the main game loop. So let's create two variables here, and let's say player.rect.x plus equal player.move. the first element will represent the x coordinate movements, and player.rect.y plus equal player.move 1, the second element of the list. And when we run the code, nothing is happening because we are not changing the vectors here, so nothing is happening. The way I'm going to implement the gravity, I'm going to play with the second element of the movement and constantly apply it on the rect y coordinates. So let's close this. It's kind of simple logic here. So we can say if player dot move 1 is 0, like there is no force on it, then player dot move 1 equal 1. So we make it a little bit heavy, in fact, something like that. You can take it that way. Else player dot move 1 plus equal player dot gravity. So this make the object just fall, I guess. Yeah, okay. And the next thing what we need to do is we just create some sort of boundary for it, so you're not going off the screen. So we make the bottom of our screen like the end of the falling, so it's like the base ground of the of our object. It can't pass it. So here also we can use simple logic as this: if player.rect.bottom greater or equal to screen height, then first player dot move 1 equals 0, and second player dot rect dot bottom equal screen screen height. So it will stay there. And the reason we need to set it to 0 is because it's not going to constantly add on to the gravity. So if, for example, we print player dot move 1, now it's 0. But if we don't do it, I guess it's make it slowly go down. Or later on we will have problem. But yeah, you see, this is the gravity is like, in fact, the object is getting heavier and heavier, and later on when we want to apply jump or collisions, this we will have a problem. So better to set it to 0 from now. And another thing we need to fix is jumping and the movements to the left and the right. So for always, most of the time I'm using the movement inside. I'm using the class itself as a part of the movement, like create a method and put all those stuff there. But now I will use directly the key binding here in the main game loop. So so here, if event the type equal Pygame dot let's say is Pygame dot key down, if events dot key equal Pygame dot key left, then player.move 0 minus player.speed. And if event.key equal Pygame.keyWrite, then player.move 0 plus player.speed. Okay, I forgot to put it back to 0. Just a second. Yeah. And also I get rid of this print statement here. Right. It's not working for now. And that's kinda odd. So why is that working? Let's see if we are affecting the player movement. So print up top here. Print player dot move. Now we are not affecting it with this key binding, and I wonder why. So if event type is Pygame key down, and if event.key equal Pygame.key left, if event.type is Pygame key down, and event.key equal Pygame player.move 0. Yeah, equal minus player.speed, and here should be just equal player.speed. Yeah, that's my bad. Okay, as you see, but now we have another problem. Like when I click into the left or right and let the key go, it's continue going to the left or right. So we have to just add a little bit more logic here, and we can continue with if event.type equal Pygame.key up, and if we can just copy these two lines from here, if event.key equal Pygame.key left, then player.move 0 equal 0, stop, and also same goes for key right, stop. So I think this will fix that continuous movement. Yeah, I push the key to the left key is going to the left, push the key, the right key, and it's going to right, and immediately when I move my finger from the key, as you see, the numbers are changing. So we have some sort of good movement. Now let's take care of the jumping. Jumping also is very easy. We just add another line of code here. If event.key equal Pygame dot which key we can use, Pygame dot like a space then player dot move 1 which is controlling the y coordinates, equal -10. Let's see, it's working. Okay, but the problem, one problem is like we can just use that key, and we can make a Flappy Bird with this system. And also this is a nice little print here. You can see how you are affecting the coordinates and using your okay. But what if we have some tiles here, or what when we don't want to jump on the air, like you can only jump when you are on the ground, right? So for that, how we can implement it? First line of code can be something like this. Something like this. So we first check if we are on the bottom of the screen. So if player.rect.bottom is greater or equal to screen height, then player can jump. Otherwise, we can't. Oh, I can. If player and else, what should I use? Else or else player that move 0 equal 0. Also here I put it in the wrong place. Okay, I put it in the wrong place. Yeah, this line I have to copy because it should work that way. I forgot my jumping part is here, space, so we put this if statement here. Just check if the player is on the ground, and if it jump, and if not, it can't jump. One more time. Yeah, I can jump only one time. Okay. Now, so we have the movement, we have the gravity, and we have the jump. So let's take care of the other part of the code, which is the tiles. We go up, we create another class, what we can call it? We can call it tile. We can call it tile. Class tile. Then Pygame.sprite, same stuff here. And can I copy? No, I don't like copy paste. Or should I do it? No. Yeah, let's copy paste everything from up. So this will be tile. Also same self x and y for coordinates, width and height for the size, and also you can add the image here, or you can even add the optional parameter here, but we are not going to do it. Everything else is same. We can keep the gravity. Maybe in some part of the game you want to, for example, push and tile and make it fall, but it's beyond the purpose of this tutorial. So we don't need the speed, we don't need the movement, and we don't need the gravity. And the rest of the code can stay. Okay, we come down here, we create another create another container, call it all tiles equal pygame.sprite.group, and let's create one tile here, or a couple of tiles, or let's do it this way: tile1 equal tile, we added on 100 and 200 below the player, and the width should be something, I don't know, 100, and the height should be 32. So all tiles dot add tile1, and here also we can come to render part and say all tiles dot draw on the screen. So, and I just changed the color of the tile class, we put it to red. It works. No, it didn't work. All tiles. Here's a typo. Okay. Now let's come to the collisions. For collisions, just check this out. We will have two types of collisions: vertical collisions, which is taking care of the bottom and top of the object, and horizontal collisions to the sides. So we have to just calculate which part of the object are collide with which part of the tile, and it's the best way is we do it in two separate functions or two separate chunk of code. And I'm going to use something from the Pygame, is Sprite Collide, and also you can use directly calculate the collision part of the object with Sprite Collide, I guess, but we are going to do it in this way here. So where is the logic of the game? Update and logics. Here I write it, I comment here the gravity, or calculate the gravity, and here let's say collisions or vertical collisions. So we make a list first of all vertical collide points, something like that. Vertical, let's call it vertical collisions. Vertical collisions equal pygame.sprite collide. It means one-to-many. In fact, this is one-to-many method. Like, it calculates between the player or the one object and many other objects. So it will be player, the first the parameter, and all tiles, and false. If it's true, when we collide, the player will be removed from the screen. So this is our container or list of the collide points, and if we print the length of the vertical collisions, when we collide, it should increase. All right, it was too fast, and here we have this, so I'm going to comment this out. Okay, it was just for a moment one. Okay, so it means like it's actually working. Then now let's go for calculating. We have to calculate for each object in the vertical collisions to do what. So we have to implement our logic here. So for tile in vertical collisions, if player dot move one or vertical movements is greater than 0, it means the player is going down. Then player dot move 1 equals 0, and player dot rect dot bottom equal tile dot rect dot top. Simple as that. And it makes it to stay on top of the tile. What if it's jumping and bang the head to the bottom of the tile? Alright, so let's bring the tile a little bit lower here. Instead of 200, let's put it on 300 and see where it will stand. Okay, and here we have. Now, because we didn't write anything for top of the object, it's just sliding up. This can be used when you want to go up from tile, or you have a ladder or something. It depends on your game. Or you have some sort of, for example, vertical platformer, you want to just go up, something like that. But we want when our player can't go on top of the tile. So if, now here another part, if player dot move 1 is smaller than 0, then player dot move 1 equal 0 again, and player dot rect dot top equal tile dot rect dot bottom. I guess this should work. Yeah, it can pass it, and it can go from this side, go from this side. All right, now I'm going to add another tile here top. We call it tile 2. Tile number 2 equal tile, it can be like 100. Oh no, let's put it on 200 or 300 and 400, and will be 132. So all tiles dot add tile 2. Oh, I guess it's too low, so I put on 350. Yeah, okay, now we can pass across this tile. So this comes to my point. We have to write another list of collision to take care of the horizontal collision. So here I'm going to edge horizontal collisions, and this is too long, but whatever, equal the same thing, Pygame dot sprite collide player and all tiles and false. So we do the same things, but just to the side. So for tile in horizontal collisions, if player that move 0 is greater than 0, means we are moving to the right. Then player.rect.right equal tile.rect.left. Let's check it out. Okay, it's not move. It's just working for right side, so we can do it for the left side too. Or if player dot move 0 smaller than 0, then player dot rect dot left equal tile dot rect dot right. But we can't jump while we are standing on the tile, so we have to modify our jump section, and that's kind of easy. Where is the jump part? Space here. Okay, so we put one condition here so it can check if we are on the bottom of the screen. But how we can see if we are on top of the screen? Top of the tile, top of the screen. So the first thing is we need to push the object down and check if we stand on something. So I call it mini collision check. So we just make something like this, pretty easy, like player dot rect dot y plus equal 2 every time we hit the space bar, and we can write like jump check or jump hits or jump whatever, jump hits equal Pygame dot sprite collide, the same thing what we did for every other collision, player all tiles and false. And here the only difference is we just check if we collide. So if length of the jump hits greater than 0, then means we are standing on something. Then here we can jump, player dot move 1 equal -10. And after if we are not standing on anything, then we release the pressure. So player dot rect dot y minus equal 2. So here in this line we just push the object down a little bit just to check if we stand on something. If we stand on something, then the length of the jump hits list going up to be 1, and after we check if it's 1, we jump. If nothing, then we put the pressure, like release the pressure and put the player in a previous position. I guess this should work, and it's working. So we can jump from here and we can jump from here. So it can be like some difficulties or some complications later on. For example, when you have another object here and it will confuse the object, like what to do with this collision. And for that you can a little bit expand your logic if you ran to a problem. For example, you can add more safety to object. So here, for example, in player dot move in player move dot 0, which taking care of the left and right, here we can just add, for example, if player dot rect dot right equal or greater than tile dot rect dot left, and for example not add, then just stay in the left side of the object or tile. but as long as you don't run to any problem, you don't need to make more complicated logic. So the complexity of the code, in my opinion, it depends on the objective of your code. So when something simply just working and you don't run into any issue, as long as it's as long as you don't find really better way of doing it, in my opinion, you don't need to do it in a different way. So I was about to add a little bit more to this tutorial, but I guess it's too long, so I will continue to add a little bit more stuff on this tutorial, but just play around with this. I'm trying to I'm trying to put another section add on to this tutorial, like how you can map your tiles from the two-dimensional lists, and how to get it from the text file, or how you can for example use the name here, for example self.name equal something, so you can refer to your tile, depends on the situation, and do different logic with that specific tile, but I will do it later. So and this would be all, I guess, for this tutorial, and as always, if you like my videos and tutorials, please subscribe, and thanks for watching. I see you guys in the next video.